All right. All right, so consider this equation, okay? You told me that you think the left-hand side looks more complex, right? Okay, so let's choose the left-hand side. So this is the format that we're going to use when we do these proofs. And I want you to stick to this format for the mere fact that when I grade your work, guys, you're going to want to be organized because you don't want me searching all over your page for information and how this thing flows, because if I have to do that, chances are you're going to probably miss points. Does that make sense? Okay, don't make me guess on what you're trying to connect in your relationships that you're trying to make. Okay, so you're going to start with choosing a side. And I say LHS for left-hand side, right? We're at LHS, and then we're going to write down what that left-hand side looks like. It's cosine theta, secant theta minus cosine theta. Okay? And now you've got options. Okay? You have options because of how we should know our operations exist in mathematics. You can distribute that cosine through. Does that make sense? And you can rewrite that as cosine theta secant theta minus cosine squared theta. Is it okay? However, does anybody know what cosine theta times secant theta is? Okay, so it's 1, right? Okay, I got cosine times secant. Those are reciprocals, right? Okay, some of you might prefer to write it this way. And I like this because it's deliberate. You're telling me exactly everything that is important. Okay, my thought is and I can gauge a lot of times whether you guys are on an individual basis really understand what you're doing, or if you're a person that goes like LHS equals cosine theta, secant theta minus cosine theta equals RHS, and you're done. Okay, well, you just skipped everything, right? When you're doing a proof, we talked about this in geometry, when you're doing a proof, you want to make sure that there's absolutely no gaps in your proof, right? Okay? If there are gaps, I'm going to, as a person grading that work, I'm going to try to attack those gaps and show that, okay, you left this out, so that's an issue. That's a problem for me in being able to be linked from left-hand side straight over to the right-hand side. So we want to be detailed. We want to provide as much information as we possibly can. I'm just trying to say don't skip steps, okay? So I'm going to write it this way, and now that would be, cosine theta times 1 over cosine theta. What's that going to give me? Okay, so it's going to be 1 when I multiply through. That's fine. I don't think you need to write it this way. But if you want to, more power to you, it's fine. Okay, a lot of times, maybe if you're going to find a PDF that's really trying to explain what's going on to their audience, they would maybe do this. Don't skip steps. You've all done this. You've all read a math textbook, and the author skips 3 or 4 steps, and you get lost, right? Okay. Let you be the author of the math textbook. Let me be the reader. Let me be the audience. Don't allow me to get lost when you're writing your proofs. Okay. So when I multiply this, now we realize that does go to 1 minus then cosine squared theta, right? Okay. Now there's a substitution that needs to take place here. Okay. There's a trig identity that needs to take place here, and you can do it one of 2 ways. Okay. I'm a proponent for doing this. I know sine squared theta plus cosine squared theta is equal to 1, right? And you guys know that as well. Can I rewrite that as sine squared theta equals 1 minus cosine squared theta? Does that make sense to everybody? Is that there the same as that? Yes. So can I make the substitution that is actually equal to sine squared theta? And that is equal to your right-hand side, right? Okay. Now, the person that does this, so let's say that I was at the stage that said 1 minus cosine squared theta. Would somebody say, okay, well, 1 minus cosine squared theta, but I know 1 is the same thing as that, isn't it? Can I rewrite that as sine squared theta plus cosine squared theta? That's the 1. Minus then cosine squared theta. And what happens there? Cosines cancel out, and I'm left with sine squared theta again, still equal to the right-hand side. Okay? Does that make sense, everybody? Okay? So you have options, but if you're, and that's the thing throughout, obviously here in this problem, that last step, maybe a lot of people aren't going to use what I did there in green. And if you did, it really wouldn't be all that hard for me to decipher. But throughout these problems, we could have people go, completely different directions with their proofs and still all arrive at the same solution, the same validity. The issue then is those people that go different routes, are they tying their pieces together correctly? Okay, are they using right substitutions? Are they using correct algebra? Because a lot of times I'll have people and they want to argue this. They want to say, okay, I did everything you asked me to. I started with a side that I thought was complex. I made some substitutions, and then I wrote down the right-hand side. But all their substitutions, all the work that they did, all their algebra they did, there might have been a lot of steps in there that they did incorrectly. And then just by happenstance, because things worked out incorrectly for them, because they didn't understand their order of operations, all that kind of stuff. They didn't understand coming up with common denominators, the nuts and bolts of algebra, that their work was not supporting of the proof. Does that make sense? Okay. So we need to make sure that we do that. And that's guys, one of the things that I think is going to be a huge byproduct for you when we start working with these and getting better at these, is that when you go to other classes, when you go to a calculus class, okay, there are proofs in a calculus class called delta epsilon limit proofs, okay, which you'll work on for a little bit, and then you start to learn some shortcuts to those things. But basically, they're proofs of a limit existing. And when you do those, you're going to use some algebra skills. You're going to use some of the stuff that we're talking about here. But I guess the byproduct of the questions we do here is that you enhance your algebra skills, okay? And then you're going to use those in other proofs. Does that make sense? You're going to choose at some point proving some relationship, some property, some principle. You're going to choose a complicated version of that principle and then work through it. Okay, how does this end up looking like this simplified algebraic relationship that I learned in the 9th grade? Okay, you guys, just kind of give you an example of that real quick. You guys know that when we talk about something of the effect, like let's just say I take A times B is equal to our square root of A times B, we know that is the same thing as radical A times radical B, correct? Okay. Well, later on in college mathematics, you prove why this is true. Okay. Do you guys remember that the square root is the same as what power? Okay, so what you would do, so the proof of this thing would look like this. The square root of AB is equal to, based on our laws of exponents, is that, right? Laws of exponents then say, oh, well, if this is a power of 1, and that's a power of 1, then we have A to the 1/2 times B to the 1/2, right? Power to a power, you multiply them. And now we go back to, basically reuse the property we took this apart with, and we put it back together. So what's A to the 1/2 the same thing as? Radical A, right? What's B to the 1/2 the same as? Radical B. So did we prove why that's true? That kind of makes sense? So that's kind of the same thing that we're doing here with these. I guess that's the learned procedures and byproduct of being able to do these proofs, is that you learn ways of doing this type of stuff, okay, that are probably more appropriate and more useful to you in other math classes than maybe these trig identities. All right, let's do, they ask you to confirm this graphically. All you got to do is graph one of those in Y1, graph one in Y2, and you're going to see that they end up giving you the same exact curve. All right, so this one says verify the identity. Cosine u over 1 minus sine u equals secant u plus tangent u. Okay, which side looks more complex? Okay, the last class made the same exact argument. Left-hand side is the more complex. So we go cosine u, 1 minus sine u. And we look at that and we start thinking, okay, is that really the more complex side? Is there any substitution that I can make there? And I don't see one, right? Okay, usually a lot of times maybe we can, when we choose a fraction, a lot of times maybe there's a secant or cosecant or tangent or cotangent in there, and we can change things to sine and cosine. And maybe then combine like terms, maybe we can create a fraction up top and a fraction on the bottom, and things start to kind of sift out and simplify. Here that doesn't happen. Now, I'm going to maybe approach this. Let's try this real quick. If something doesn't simplify, maybe you can multiply by 1. Maybe you can multiply 1 to make things a little bit different, okay? Multiplying by 1 never changes my value, right? Okay, so I'm allowed to do that. I'm allowed to multiply by anything I want to as long as that anything is 1. Okay, well, multiplying by just the numerical version of 1 is kind of stupid. If I multiply by 1, nothing happens, right? But if I multiply by that, maybe something starts to happen. Okay? Is that still 1? Now, why would I have chosen that? What is 1 plus sine u in relation to the stuff that's over here? Is it relatable to that? What is it compared to that? What's the vocabulary word for that? Not opposites. Starts with a C, and you do it in English. Conjugates, right? Okay. So if I multiply, I get cosine u plus sine u, cosine u up top, right? That thing a little bit closer. And on the bottom, I get 1 minus sine squared u, right? Okay, 1 minus sine squared u. Well, what's 1 minus sine squared u? Cosine squared. Okay, cosine u plus then sine u tangent u. And on the bottom, we have cosine squared u. Is everybody okay with 1 minus sine squared being cosine squared? All right, so it's something to commit to memory. Obviously, that thing there are 3 different versions of that thing just using subtraction, right? You got that version, subtract cosine squared from both sides, you got another version, subtract sine squared from both sides, you got another version, right? You get new versions by dividing by sine squared. You get new versions divided by cosine squared, right? And those new versions even have newer versions of themselves by subtracting from both sides. Okay, so when I see 1 minus sine squared u, hopefully the Pythagorean identity stuff kind of comes into mind. It comes into play. Here's something. If I had like 2 plus 3 times 4 all over 6. 6 is considered a common denominator for that sum, right? Can I pull it apart and write it as 2 over 6 plus 3 times 4 over 6? All right, so that's usually what happens a lot of times in these identities is that we work backwards with our common denominators. I'm going to pull this apart and write it as cosine u over cosine squared u plus then sine u. I don't know why I put tangent there. I think I was looking at that instead of that. Okay, so that should be a sine u, cosine u. My apologies. So sine u, cosine u over then cosine squared u. Okay. Now we're starting to see, after a couple substitutions, we're starting to see some stuff here dwindling, right? What's cosine u over cosine squared u? 1 over cosine u, right? Okay. Now over here, what's going to happen with these cosine u's? Yeah, that cosine u is going to cancel with one of these, and you're left with sine of u over cosine of u, right? What's 1 over cosine u? Secant. What's sine over cosine? Tangent. Does that equal the right-hand side? Right? So here, you did choose an appropriate side here. However, we had to have that, look at cosine u over 1 minus sine u. We had to look at that and say, well, that doesn't really make a whole lot of sense in regards to simplifying, substituting, and then I have to have in the back of my mind, well, I can multiply by 1, and maybe that will adjust. I didn't know if that was going to work, guys. Okay, because last class what we did is we got this and said, well, we don't know any substitutions to make. We tried doing some weird things by multiplying by, just multiplying both these denominators, or both these components of the denominator by cosine, doing something to the top, and nothing really worked out. It didn't really get much simpler. So what we did is say, well, that ain't the right choice. Let's go right-hand side. If I go right-hand side, secant u plus tangent u, and then they say, well, secant is 1 over cosine u, tangent is sine over cosine, right? Okay, and now I get 1 plus sine u over cosine u. Okay, still not really convenient, okay, but that's pretty close to what I've got here, right? It's just flipped, and the sine is negated, right? So the way that we address that's the same as what we did the first round. If you ever see that relationship where you're close to what you're trying to prove, but it's upside down and maybe negated, that's the identifier for me that I probably got to use conjugates. Okay, so I'm going to go 1 minus sine u again, or 1 minus sine u, and now I get 1 minus sine squared u. Now here's the thing that I want to make sure, and it's the reason I want to go through this route. It's the same thing that we did when we started talking about how to work with rational equations. If you ever remember working with rational equations, a lot of times we don't multiply the denominators out because we won't recognize cancellations that can occur. Okay? So the same thing happens here. I don't want to multiply that out because I'm not going to see any cancellations occur later on. So I'm going to write cosine u, 1 minus sine u. Just a thing to think about. Do not multiply your denominators out. Why would I do that? What's 1 minus sine squared? Cosine squared, right? And now you get cosine u, 1 minus sine u. And what happens with your cosines? Cancel out. So cosine u up top, 1 minus sine u on the bottom. And that is equal to our right-hand side, right? Okay. Left hand? Nope. Yep. Cool. Okay. Sometimes you will see when a proof is done, they'll put a little square here, and then they'll shade it in. I forget the guy's name that started doing that in like the 1900s. They call that a tombstone. Just call it his name and the tombstone after it. Or you might see that phrasing, QED, which is a kind of abbreviation for a Latin phrase that basically says something to the effect of what was asked to be proven has been proven. Okay? So if you ever see, as you're working through looking at other people's work, if you ever see a black box or that QED, it just basically says proof is complete. We're done. Okay? But I wanted to show you those two routes because it hopefully exemplifies the idea that it doesn't matter what side you start with, right? Especially if you understand your algebra skills pretty well, you can manipulate either side. Now, I honestly think that second route was a little bit simpler because I started to see substitutions right away, and it just got the ball rolling. And a lot of times if you can start making some substitutions, get the ball rolling, it gets the thoughts flowing a little bit better, and maybe you start seeing substitutions that maybe you initially would not have recognized. Okay. Last class we got through this one. We'll start with this one tomorrow. Okay, it's not too bad. But this is one where you've got to actually you're going to manipulate the left-hand side, and you're probably not going to realize that it's the right-hand side. So then you take the right-hand side, and you start manipulating it. And eventually you get both sides to look identical, and then you can say, oh, we're done. Okay? Those types of proofs, guys, on WebAssign are really hard for them to assign, okay, because obviously you got different routes. It's going to be really hard to show all your work and stuff like that. So sometimes they will kind of autofill like a paragraph of stuff and ask you to go step by step, and they just kind of, you remember on Math Excel when we did proofs in geometry where they fill in 3 or 4 on the left-hand side, 3 or 4 on the right-hand side, and they just try to structure your way of doing the proof, even though there might be 3 or 4 different ways. They want you to do it this one way. Some of the questions we see in WebAssign are going to kind of be like that, where they force you to go down one route. On your tests and quizzes, it's going to be open-ended, okay? Basically, you choose the route you want to go, and if there's no gaps or flaws within your route, you're going to get your points.
Pardon the interruption, but this is just a reminder that there will be a gatekeepers meeting in the auditorium during Wildcat time today. Again, there will be a gatekeepers meeting in the auditorium during Wildcat time. Thank you.
My plan, guys, I don't know if I said this when I handed out those quizzes. I'm going to get you a practice test for Thursday. Okay, I'm going to get it out later today. Test on Thursday. It's going to be a one-day test over Chapter 6 and parts of just basically a couple of these simplifying questions. Then we can use, hopefully if everybody's here, we can use Friday as a day of notes or whatever. But it's going to be intended to, because Friday's only half a day. Okay, we got 2 hour delay, so we're 30-minute periods. So I don't want to use that as a test day. And I was going to do it on Wednesday, but my computer crashed this morning, and I was afraid I wasn't going to have anything. So I told the first period that we'll just push it back till Thursday, and then my computer started working again. So I don't want to go back on what I told them. So Thursday, Chapter 6, part of Chapter 7 test. There will be questions that are very similar to that quiz I gave you. And I'm going to ask you to graph the sine, cosine, tangent, secant, cotangent, not all 6 of them, but maybe 2 or 3 of them. So please know how to do that. And like I said, I'll get that out to you as soon as possible today. Not back. You too.